SpaceX CEO Elon Musk recently set a highly ambitious target, announcing that uncrewed Starship rockets could launch to Mars as early as 2026. If those ships land intact, human crews will be right behind them. But the advanced engineering of the rockets obscures a brutal reality. The environment on Mars is incredibly hostile to the human body. In biology, this is known as an evolutionary mismatch. For millions of years, our genome has adapted to specific conditions: Earth's exact gravity, atmospheric pressure, and magnetic shielding. Taking that biology and dropping it onto a barren, irradiated rock is completely out of sync with how we are physically built. NASA identifies 5 primary hazards to colonization: space radiation, isolation, distance, altered gravity, and hostile environments. These human hardware bugs must have engineered patches, otherwise the body breaks down, guaranteeing mission failure before a colony is established. The physical toll begins the moment the rockets leave Earth's orbit. Mars is roughly 140 million miles away. To traverse that distance, crews will spend 6 to 8 months locked inside a heavily confined spacecraft. During that transit, astronauts will experience the Earth out of view phenomenon. Every explorer in history has always had the physical ground of their home planet beneath their feet. These crews will be the first humans to watch our planet shrink and entirely vanish into the background of deep space. That vast physical distance also creates a severe communication bottleneck. Radio signals travel at the speed of light, but even at that velocity, a single distress message will take up to 22 minutes to reach mission control and another 22 minutes to get a reply. Combining tight confinement, the visual loss of Earth, and extreme communication delays creates immense psychological pressure. Psychiatrists warn this specific environment is ripe for mass psychogenic illness, a condition where severe depression, paranoia, and aberrant behaviors spread rapidly from person to person through the crew. While the mind struggles with isolation, the body faces an invisible physical attack. Outside Earth's protective magnetic field, galactic cosmic radiation easily penetrates the metal hull of a spacecraft. These high-energy particles smash into human DNA, breaking the molecular strands and causing cellular damage that increases an astronaut's lifetime risk of cancer by 33%. As the fluid pools in the head, the brain swells and physically crushes the back of the eyes. This condition, called spaceflight-associated neuroocular syndrome, or SANS, causes permanent vision damage. To counteract this physical decay, astronauts will have to undergo grueling, repetitive physical exercise. To enforce that routine, scientists are looking to augmented and virtual reality gaming to trick the brain into enduring the strain. Consider this image of Pokémon Go being played in front of the Eiffel Tower. When this game launched, its digital reward system accidentally drove players to walk 144 billion extra steps in a single month on Earth. Applying similar AR mechanics in space provides the exact psychological motivation needed to keep astronauts moving. Using digital escapism to gamify exercise is a biological necessity. It is required to keep the skeleton strong and the brain functioning in a zero-gravity environment. This panorama highlights the lethal reality waiting on the surface. Mars features freezing temperatures dropping to -100 degrees Fahrenheit, low gravity, and highly toxic red dust. Most pressing of all, the thin atmosphere is 95% carbon dioxide. Rockets cannot carry enough heavy oxygen tanks to sustain a colony permanently. The solution is in situ resource utilization, which means generating breathable air using the raw materials already present on the planet. This is NASA's Perseverance rover, currently operating on the Martian surface. Inside it is a device the size of a microwave called MOXIE. Through an electrochemical process, MOXIE successfully sucked in the toxic Martian carbon dioxide, ripped the molecules apart, and produced 122 grams of pure, breathable oxygen. Proving this chemistry works was a massive step. Now, engineers have to scale that synthetic oxygen generation to industrial proportions, producing enough gas for colonists to breathe and enough liquid propellant to fuel the return ships. Once a colony has air, it still needs food. Relying on constant resupply shipments from Earth over 140 million miles of space is financially and physically impossible. This image shows a prototype bioregenerative life support system. Future colonies will rely on similar setups, cultivating specific strains of algae like Limnospira indica in massive tanks to scrub the air of carbon dioxide while simultaneously harvesting a protein-rich food source. These plants serve a deeply ingrained evolutionary purpose. The savanna hypothesis and a concept called biophilia suggests that humans have a hardwired genetic requirement to interact with nature. Studies demonstrate that simply touching a leaf or viewing a green plant significantly lowers blood pressure, reduces fear, and alters brainwaves. Because of that biological wiring, a Martian greenhouse operates as a vital psychological sanctuary, lowering crew stress and keeping colonists mentally tethered to their earthly origins. Surviving Mars requires patching our biology with a highly specific technological ecosystem. The resulting colony will not be a cold, sterile metal bunker, but a vibrant synthetic hybrid of Earth's own biosphere. We will ride incredibly advanced rockets across the solar system, only to survive by relying on ancient algae, virtual reality video games, and synthetic oxygen generators. With uncrewed launches targeted for 2026, the colonization of Mars is rapidly shifting from a math equation into a grueling test of human adaptability. Knowing the extreme toll this journey will take on the human body and mind, would you volunteer to be one of the first colonists? Let me know in the comments below, and make sure to subscribe for more deep dives into the science of space exploration.